Welcome to today's developer presentation. Today we're going to be discussing how to define and implement a test strategy document. This is just another in our series of integrating testing into your development flow. So even though testing differs between organizations, almost all software development organizations follow some sort of test strategy document to achieve their goals and ensure they are following best practices. Not only is it used by an organization to define their test strategy, it is also one of the most important documents in test deliverables. Like other test deliverables, this document can be shared with the customer for better understanding about the scope of the project, test approaches, and other important aspects. In some cases, for example, the sales team of an organization could use this document to highlight the company's approach to testing, deficit management, and release schedule in order to land a sale. So once the test strategy is ready, test teams will start writing the detailed test plans and continue further phases of testing. Unfortunately, though, in the Agile world, some companies are not spending time on test plan preparations due to minimal time for each release. Instead, optimizing or opting to maintain a test strategy document, maintaining this document for the entire project leads to mitigate the unforeseen risks. So our agenda today, we're going to look at what is a test strategy. So I kind of just gave you a little overview of how a test strategy is used within an organization. So we're going to dive into test strategies from pretty much the beginning of the idea of the test strategy, go through all the different pieces of the test strategy, and at the end, we're going to look at the tips on writing a successful test strategy. We'll even look at some sample test strategy templates that I found online that are really good. You can just go download them and kind of fill in the blanks. But before you do that, you kind of really need to understand what the test strategy is. And we're also going to look at what the difference is between a test strategy and a test plan. So what is a test strategy? Well, essentially, a test strategy deals with the test coverage features to be tested. Features not to be tested, estimation, scheduling, and resource management. That was a test plan. Test strategy, though, defines the test approach to be followed in order to achieve the test objectives and the execution of test types defined in the testing plan, like the test objectives, approach, test environment, automation strategy and tools, and risk analysis with contingency plans. So basically, it's a set of guidelines that explain test design and determine how the tests need to be done. So the components of the test strategy are listed here, and we're going to go through them through the rest of this presentation. So the test strategy versus test plan. So the test plan is a vision of what you want to achieve, and the test strategy is an action plan designed to achieve this vision. So the test strategy essentially means how you are going to test the application, meaning you need to explain the exact process and strategy that you're going to follow when you will get an application for testing. Many companies strictly follow a testing strategy template, while others tend to forgo this document completely due to time or budgetary constraints, which is a shame because even without any standard template, you can easily create a simple test strategy document and have it still be effective. So what exactly is a test strategy document? Well, it consists of an outline that describes the testing approach of the software development cycle and is created to inform project managers, testers, and developers about some key issues of the testing process. So a testing strategy can be carried out by the project manager. It can say what type of techniques to follow and which modules to test. We can narrate about the general approaches to the test project. Once a test strategy is defined, you really don't want to change it, whereas with a test plan, it's kind of a more fluid document. It is a long-term plan of action. You can abstract information that is not project-specific and put it into a test approach. In smaller projects, it is often found as a section of a test plan. It is set at organization level and can be used by multiple projects. So a test strategy essentially is an overlying guideline or plan on how you want to basically achieve your vision. And then the test plan is actually doing it. Steps to build a good test strategy. These are the steps we're going to cover today. We're going to discuss scope and overview, the test approach, your test environment, the types of testing tools you can use, industry standards that you typically want to follow when building your application, your testing deliverables, how to test the matrices of these deliverables to make sure that they are actually testing the way you want them to test. We're going to look at building a requirement traceability matrix. We're going to discuss release controls, risk analysis, some other reporting tools, test summary, and how to review and approvals. Scope and overview. In this section, we will mention the scope of testing activities, essentially what to test and why to test, and mention an overview of the overall user acceptance testing. For example, let's create a new application, say a product catalog application, which offers an affiliation service. So the scope of what to test and why to test would be to test the functionality of the affiliation service and make sure that it gives the customer value. So like it states here, basically you're wanting to define the scope, define what the application wants to do or piece of the business rules or business needs. And then you're going to actually define what to test and why to test. So you're going to look at things like the project overview, along with the information on who should be using this document. That typically steers you towards who is the application for, who is the end user, because the business analysts or the programmers, when they typically take a problem or they take a concept for an application, they have it in their mind as to how they want to build it. But at the end of the day, it needs to meet the end user's goals or the end user's requirements, not necessarily the programmer or the business manager's vision. We need to define testing activities and phases to be carried out with timelines with respect to overall project timelines defined in the test plan. This basically helps you keep the project on scope and avoid scope creep or any additional problems. So if a particular piece of the application starts running off the rails, this will help you identify that and hopefully get you back on track. This also includes details like who will review and approve this document. So this is going to be like the business managers, the customer, project managers, test managers. So once you actually build the test strategy document, once it's finalized, everyone needs to sign off on it so everyone's on the same page. The test approach section defines the testing process, level of testing, roles, and responsibilities of every team member. In test execution, there are various activities like adding new defects, defect triage, defect assignments, retesting, regression testing, and finally, test spinoffs. You must define the exact steps to be followed for every activity. So let's look at how this would work for the defect management cycle. So starting with the process of how to log a new defect. So in order to log a new defect, the steps would include where to log in, how to log a new defect, what should be the defect status, who should defect triage, who to assign defects after triage, and so on. So we can break the testing approach into three sections. So we have the test levels that list out the level of testing that will be performed during QA testing, such as unit testing, integration testing, system testing, and user acceptance testing. For instance, testers are responsible for integrating testing, system testing, and user acceptance testing. The testing type section lists out testing types that will be performed during QA testing defined in the test plan. It describes why it should be conducted along with details like when to start, test owner, responsibilities, testing approach, and details of automation strategy and tools if available. These will include things like unit, integration, system, regression, installation, uninstallation, usability, load performance, and security testing. And last, we have roles and responsibilities. These describe the roles and responsibilities of things like the project manager, project lead, and the individual testers. The test environment setup should outline information about a number of environments and require setup for each environment. So the test environment, this section lists out the hardware and software for the test environments in order to commence the testing activity. This could also include things like providing clear instructions on how to create test data, either generate data or use production data by masking fields for privacy, or using tools like Rob's creating the random data generator tool for things like his database and that. Other things, define test data backup and restore strategies. Testing environment database may run into problems due to unhandled conditions in code. Backup and restore processes should define problems due to unhandled conditions in code. Backup and restore processes should define who will take backups, when to take a backup, what to include in a backup, when to restore the backup, and who will restore it, and data masking steps to follow if the database is restored. An example would be if your organization needs to separate test environment for functional testing and another for UAT. You will need to define the number of users supported on each environment, access roles for each user, software and hardware requirements like operating systems, memory, free disk space, and numbers of systems, and so on. Other things to think about within a testing environment. So talking about the data there for a second. So in a lot of cases, most software environments will have a test environment, a development environment, and a production environment. In some cases, they will have a UAT or a demo environment. Typically, at least once a quarter, maybe 6-7 times a year, you want to essentially refresh your development environments because they get corrupted over time as you code things, you put dummy data in there. You want to refresh it with what's in production. So you're going to take a backup of your production code and flush it over your other environments. However, if you're dealing with HIPAA, Sarbanes-Oxley, or very private or secured customer information, you need to either encrypt, decrypt, or in some way massage that data so that it's not exposed to your testing environments. That way, all the information is still safely secured in production, and you're not exposing yourself to a lawsuit in your other environments. Testing tools. This section will describe the testing tools necessary to conduct the tests. Define test management and automation tools required for test execution. For performance, load and security testing describes the test approach and tools required. Mention whether it is open source or commercial tools and how many users are supported on it and plan accordingly. An example would be, say, a test management tool, some type of bug tracking tool, or an automation tool. Something else to consider within the testing tools is licensing. So if you're dealing with an open source project like SoapBear, they actually have a commercial project along with an open source project. In some cases, if anywhere in an organization they have bought a licensed copy of that software, you cannot use the open source version anywhere in the company. You are now liable to have a licensed copy of their software. You can't go back and use the open source community version. So these are things to be careful of when you're looking at testing tools or any type of tool within an organization. So just be cognizant of the licensing. Industry standards to follow. This section describes the industry standards to produce high-quality systems that meet or exceed customer expectations. So usually this is the project manager describes the testing modules and procedures which need to be followed to achieve the goals of a project. And these are some of our test deliverables. This section lists out the deliverables that need to be produced before, during, and at the end of testing. And essentially, so these are the test artifacts which are given to shareholders of a software project during the SDLC of a project. A software project which follows the SDLC undergoes different phases before delivering to the customer. In the process, there will be some deliverables in each phase. Some of the deliverables are provided before the testing phase commences, and some are provided during the testing phase and rest after the testing phase is completed. So just to give you a little breakdown of these. So a test strategy is a document which captures the approach on how we go about testing the product and achieve the goals. The test plan is a document which contains the plan for all the testing activities to be done to deliver a quality project. Effort estimation report. In this report, usually teams mention the effort put in to complete the testing process by the test team. Test scenarios gives the idea of what we have to test. Test scenarios like a high-level test case. test case scripts. Test cases are the set of positive and negative executable steps of a test scenario, which has a set of preconditions, test data, expected results, post conditions, and actual results. Our test data is the data that is used by testers to run the tests. The requirement traceability matrix, RTM, is used to trace the requirements to the test that are needed to verify whether the requirements are fulfilled. The defect report or bug report. The purpose of using defect reporting templates or bug reports is to convey the detailed information like environmental details, steps to reproduce a bug, so that these can be passed along to the developers. Test execution report contains the test results and the summary of test execution activities. Graphs and metrics. Software test metrics is to monitor and control processes and products. It helps to drive the product towards the planned goals without deviation. Test summary report contains the summary of test activities and final test results. Test incident report. This contains all the incidents, such as resolved or unresolved incidents, which are found while testing the software. Test closure report is a detailed analysis of the bugs found, bugs removed, and discrepancies found in the software. Release notes, these will be sent to the clients, customers, or stakeholders along with the build. It contains a list of new features, bug fixes, or enhancements. Installation configuration guide. This guide helps to install or configure the components that make up the system and its hardware and software requirements. User guide gives assistance to the end user for accessing the software application. Test status report is used to track the testing status. It is prepared on a periodic or weekly basis. It contains the work done till date and work remaining pending. Weekly status report, more of a project manager to client, is similar to the test status report but generated weekly. So let's kind of break down into each of these a little more. So the first thing we're going to look at is testing matrices. So this section describes the matrix that should be used in the project to analyze the project status. And we have two different types. We have the process matrix and the product matrix. So software test matrix is to monitor control processes and products. It helps to drive the product towards the planned goal without deviation. So within the product matrix, this essentially takes place in two different parts of the application SDLC. So the first two are used in the process of test preparation and test execution, while the bottom are generated during the test execution phase, which makes sense. So the first part, during the test preparation, we're going to define our test cases. We're going to define our test design coverage. And what gets generated are going to be our test execution productivity, our test execution coverage, what tests passed, failed, and or blocked. So the test case preparation productivity is used to calculate the number of test cases prepared and the effort spent for the preparation of test cases. Test design coverage helps to maintain the percentage of test cases covered against the number of requirements. Test execution productivity determines the number of test cases that can be executed per hour. Test execution coverage is used to measure the number of test cases executed against the number of test cases planned. Test cases passed is used to measure the percentage number of test cases passed. Test cases failed is used to measure the percentage number of test cases failed, and so on with the block. So it tests the measure percentage number of test cases blocked. And here are some of the formulas for the process matrix. So the test case preparation, number of test cases divided by effort spent for test case preparation. In our example here, we start out with 240 test cases. We estimate that we spent 10 hours for test case preparation. So our test case preparation productivity is 240 divided by 10, which gives us 24 test cases per hour. Test design coverage, total number of required maps to test cases divided by total number of requirements. So here we have total number of requirements 100. Total number of requirements maps to test cases is 98. So 98 divided by 100 times 100 gives you your percent of 98. Test execution productivity, number of tests executed, effort spent for execution of test cases. So number of test cases executed, 180, effort spent divided by 10. That gives us our 10 test cases per hour. Next, we have test execution coverage. So we have total number of test cases executed divided by the total number of test cases planned to execute, again, times 100 for percentage. So here we have 240 for planned executed, total number of actually executed, 160. I accidentally put that backwards, so the test execution should be 160 divided by 240, which tells you that you're only able to execute 75% of the test cases that you had actually planned to execute. So you're probably missing 25% for this particular sprint. Test cases planned. So total number of test cases passed. Test cases passed. Total number of test cases divided by total test cases to execute. 80 divided by 90. So you have an 89% pass ratio. Again, failed. Total test failed divided by executed. So that tells you your breakdown there and same block. Next, we have our product matrix used in the process of defect analysis phase. So we're looking at things like error discovery rate, defect fix rate, defect density, defect leakage, and defect removal efficiency. So error discovery rate is used to determine the effectiveness of the test cases. Defects fix rate helps to know the quality of a build in terms of defect fixing. Defect density is defined as the ratio of defects to requirements. Defect density determines the stability of the application, and this is really key. A lot of companies actually miss this one. Defect leakage is used to review the efficiency of testing process before the UAT. Defect removal efficiency allows to compare the overall defect removal efficiency, and these are the defects found pre and post delivery. So let's go look at those formulas. So our error discovery rate is the total number of test cases executed divided by total number of defects found. So if we have 240 test cases and we found 60 defects, that tells us that our error discovery rate is 25%. Defects fix rate is the total number of defects reported at fix minus the total number of defects reopened, and then the total number of defects reported at fix plus the total number of new bugs due to fix. Again, multiplied by 100 to get your actual percentage. So what that breaks down to is, so we have total number of defects reported is 10, total number of defects reopened is 2, so total number of new bugs to fix is 1. So we take 10 minus 2 since we only need 8 because 2 were reopened, and total new bug fixes were 1, so 10 plus 1. Divide that, so we have 8 divided by 11, which gives us a 73% defect fix ratio. Defect density, total number of defects identified versus actual size. So total number of defects identified is 80. Actual number of defects is 10, which tells you that your defect density was 8. Defect leakage, number of defects found in UAT, divided by the number of defects found before UAT. So here, number of defects found was 20. Number of defects found before UAT was 120. So the defect leakage is about 17%. That means that development caught probably about 73%. So that's not bad. Defect removal efficiency, total number of defects found pre-delivery, divided by the total number of defects found pre-delivery plus post-delivery. So total number of defects found before delivery, 80, and found after 10. So you have a total of 90 and 80. So basically you add these two together, it gives you 90, and so you have an 89% removal efficiency. The requirement traceability matrix, or RTM for short, used to trace the requirements tests that are needed to verify whether the requirements were fulfilled, also known as the traceability matrix or cross-reference matrix. This is kind of where you can list out your business cases to your test cases. So a simple RTM looks like this. So you assume X number of requirements. Our matrix would look like this. We have a listing of requirements and our traceability. So here on the right are business requirements. So we list all of our business requirements out from left to right, from one to however many business requirements we have. And then we list our test cases on the left side column down from one to however many test cases we need. So for example, assume we have total test cases identified are 5, and we have 4 business requirements. So we would list out business requirements from BR 1 to 4, and then we list out our test cases, and then we check off which business requirement that test case addresses. A lot of companies don't do this, and I'll tell you, if you do this right at the beginning during the design development phase, by the time you get to the testing phase, this makes testing so much easier to make sure that you are testing the actual requirements in your test cases. There's a lot of times where a lot of test cases will test functionality or test something on the screen, but that's not actually a business requirement, and some business requirements are totally missed. So this is a great way to make sure that you're mapping at least a one-to-one for business requirements to a test case. Types of RTMs. So we have forward traceability. Mapping requirements to test cases is called forward traceability matrix. It is used to ensure whether the project progresses in the desired direction and make sure that each requirement is tested thoroughly. Mapping test cases to requirements is called backward traceability matrix. It is used to ensure whether the current project remains on the right track and make sure that we are not expanding the scope of the project by adding functionality that is not specified in the requirements. Bidirectional is mapping requirements to test cases, forward traceability, and test cases to requirements, backward traceability. It is used to ensure that all the specified requirements have the appropriate test cases and vice versa. Advantages of an RTM: you get 100% test coverage. You get to identify the missing functionality easily. It makes it right there in your face. You know what you're testing. You know what's missing. Identified test cases which need to be updated in case of changes in requirements, and easy to track the overall test execution status. Now, RTMs do take a little bit of time to create, and they can be a little bit of a pain to maintain over time if you have a lot of business requirements to test cases. But if done right and if maintained correctly, this will save you time and time again while testing your applications to make sure they meet the current existing business requirements and that the changes don't break anything. Release control. So unplanned release cycles could result in different software versions on test and UAT environments. We definitely don't want that. So we create some type of release management plan with proper version history to ensure that the test execution of all of our releases are stable so that we know we're testing apples to apples and not apples to oranges. An example of a build process should answer the following questions. 1, where should builds be made available? 2, where it should be deployed? 3, when to get the new build? 4, from where to get the production build? 5, who will give the final go that this will go to production? And then 6, before we go to production, there has to be a go, no go for production release. So you have at least 5 or 6 steps in your release control before you go from development to production. Risk analysis. List all the risks that you envision. These need to provide a clear plan to mitigate these risks and also a contingency plan in case you see these risks in reality. Also, you want to identify all the testing risks that will affect the testing process and specify a plan to mitigate the risk. Reporting tools. So these are some of the common reporting tools that are out there. Bugzilla, we've talked about that on multiple nuggets. We've talked about Jira, Mantis, Track, and HP's ALM, which is now Micro Focus. Most of these are free. You can go check them out yourself, and some of them do require a small membership fee. But these are great because they essentially outline how you essentially keep track of your defects and issues and track them in a nice reporting tool. Test summary. This section lists out what kind of test summary reports will be produced along with the frequency, and test summary reports will be generated on a daily, weekly, monthly basis depending upon how critical the project is. Review and approvals. When all these activities are defined in the test strategy plan, it needs to be reviewed for sign-off. So once The whole test strategy plan is put together. You need to kind of get everyone in the room, project managers, business teams, development teams, and make sure everyone understands the test strategy plan and everyone signs off on it. If you don't and there are problems with it, your test strategy plan is not going to work successfully. You also want to create a summary of review changes in order to track the beginning of the document along with who approves it and the date in the comments. So if there are changes made, make sure you kind of have an appendix at the bottom to keep track of when changes were done to the document before it was signed off on. Bear in mind, this is a living document and should be continually reviewed and updated with the testing process enhancements. Now, with that being said, once the overall scope of the testing plan is done, that needs to be essentially signed off on and locked in stone. Then your testing plan will get updated with the test cases and your test suites will be updated there. That'll be more of the fluid document. This is essentially a living document until you have defined the full document and have it in place, unless things change within the business rules. Here's some tips on writing a successful test strategy document. One, you can include product background in the test strategy document. So in the first paragraph of your test strategy document, answer things like why stakeholders want to develop this product. This will help you understand and prioritize things quickly. Two, list all important features you're going to test. If you think some features are not part of this release, then mention those features under the features not to be tested label. Three, write down the test approach for your project. Clearly mention what types of testing you are going to conduct. For example, functional testing, UI testing, integration testing, load stress testing, security testing, and so forth. Four, answer questions like how are you going to perform functional testing? Manual or automation testing? Are you going to execute all test cases from your test management tool? Five, which bug tracking tool are you going to use? What will be processed when you find a new bug? Essentially, how will you process the defect? How will you report them? Six, what are your test entry and exit criteria? Seven, how will you track your testing process? What matrices are you going to use for tracking test compliancy or completion? 8, task distribution. Define roles and responsibilities of each test member. 9, what documents will you produce during and after testing phase? 10, what are risks you see in test completion? So when you get to the end, what are the risks that you think you will see? So let's recap. We've covered pretty much the full overview of a test strategy document is. We discussed some of the differences between the test strategy and the test plan. We've kind of walked through how to build a good test strategy, and we've looked at tips on writing a successful test strategy. This time, does anyone have any questions?
You mentioned right there at the end in putting together your document, listing out all the functions that you're going to test. How do you see that sort of doing that bit of documentation? It feels a little bit like almost reiterating the requirements. So how do you how do you distinguish between the requirements document versus getting into your test strategy and how you're going to address the functions then or the features at that point?
That typically comes with the requirement traceability matrix. So when you sit down and you list out your business requirements and your test cases, this is kind of where that falls in. And then from there, you go out in your test plan is where you identify the testing risks and things of that nature.
Okay, that makes sense. So you basically have, to some extent, you've covered that and you cover that in your requirements, but then you come here and I guess flesh them out a little bit more, add a little more detail as needed for the testing piece of it, right?
Correct.
Okay. All right, good. That's what I thought, but just wanted to make sure I was clear on that.
Yeah, this is mainly a strategy. The testing plan is where you get into the specifics of the test cases and that. But at the high level, you want to at least identify that, okay, well, this business requirement potentially can have these 3 or 4 test cases and so forth and so on. Now, once you get the test plan done and you flush out all the test cases and requirements, you can then just easily go back and add to that matrix as you're building out the test cases.
Cool. Thank you.
Any other questions?
So how do you determine you've covered everything that you can think of in like your test plan? Like, okay, according to these requirements, this will cover all the testing that we can think of on this project. Is there a way you can using?
Well, bear in mind, that's more the test plan than the test strategy. The test strategy is more of a high-level testing layout that you can apply not just to one project, but to all projects within a company or an organization. So, for instance, let me jump out for a minute and actually show you what one looks like. So here is a test strategy template. You can find this at strongqa.com. Actually has some pretty good templates out of all the sites I looked at. So this one here is their test strategy template. And here you put in your product name. Again, you want to version and date it. Here's your document control. So title, version, electronic file, author, contributors. So you keep track of everything that's going on. Change control. So here, working on draft, not yet for review. So once it's finalized, once you get done, then you'll have multiple versions and you'll have a sign-off date. And this will take a couple iterations. But typically, this should be done before any development really gets started, because you want to flush out most of the requirements within the business requirements in this document before you kind of really start coding. So here you got your table of contents. So we got your test strategy identifier, test items, features to be tested, your approach, your pass-fail criteria. So this is kind of some of the things you were asking about there. Once you think you have all your pass-fail criteria there, your test deliverables, then you just come in here and you start filling it out. Your approach, your analysis. So as you can see here, so test breakdown, test cases are written and peer reviewed. So as you can see, this is, again, more of a high-level document to your test plan.
Oh, okay.
And the reason I wanted to talk about this one, I'm probably going to do another presentation on test plans later. I actually have about 12 lessons kind of breaking down each of the levels of testing with development and just going into testing itself. So bear in mind, so last time we talked about, thinking about testing from a developer standpoint. This time, we're now looking at building the test plan. So before we even really start coding, we take the business requirements, we build our test plan, and then we can start coding, and then we can start building our test cases. So this is a high-level document. How are we going to do our calculations? What calculations do we want to do? Like total time spent on execution times, which is funny because I do a lot of this currently, and a lot of managers don't realize what the numbers are that I'm sending them. And now that I've actually gone through this presentation, I'm actually going to probably send a summary of this, some of these to some of my managers where I currently work, to give them more feedback and let them actually know what the numbers are. So when I actually say, hey, there's failures, they need to stop and take a look at it for a minute, because it may really be an impact to the production release. So here's like a table of issue severity. So here you can do major, minor, crash level. Now, if you're using things like Bugzilla and Jira, these are kind of already pre-built for you, but you can add additional issue levels if you want. Suspension criteria, your test deliverables. So you got your test plan, your test schedule, your test breakdown, test cases. So see here again, this is a high level to your test plan. And in a sense, this is also a high level to the whole SDLC process, because really this is within the resource and requirements gathering document and documentation. So you're putting all this in kind of at the beginning before you really get into coding and before you get into testing. Like testing tasks. So I like this. So you have your hardware, your software, again, things that a lot of people kind of overlook in documentation, but really needs to be there unless you're dealing with a full cloud-based system. But even there, you still need to know what back-end hardware and software is installed so you know what's being deployed. From a testing standpoint, you may need to only be worried about mobile devices or browsers. But there again, from a coding standpoint, and even from a UAT or a unit testing standpoint, this information is still required so that you can actually build unit tests to test on the actual system. Here's your response matrix. So see, this makes a little more sense looking at this than how I tried to do the template generically, but provision of technical documentation is provided by the project manager, development manager, test engineer. So that's your responsibility matrix. Risk contingencies. So delays in delivering, high. Who signs off on what? So that's a pretty good template. I like I said, I like some of the ones they have. They have some blank ones. They have some simple ones. So if you have time, go out and check out some of these. All right, thank you. We appreciate your time and would love to discuss any other topics or this topic with you further. You can send us your questions, comments, and suggestions through any of these methods, info@developer.com. You can go to our contact us on our website. You can also follow us on Twitter @developer, or we're on Facebook at facebook.com/developer. Our goal is making every developer better. Thank you. Have a great day.